Hi folks, we're going to take a look at page 103, number 18. So let's take a look at the question. They want us to find the values of m and n such that both of these polynomials are divisible by x minus 2. Okay, so even before I start thinking about how to solve this problem, the fact that I'm looking for two variables should be giving you a sense that we might have to solve a system of equations here, because normally that's how we solve for two variables, is we need two equations, hopefully two linear equations, to solve for that. Okay, so let's take a look at what they tell us. They tell us that both of these polynomials are divisible by x minus 2. That means x minus 2 is a factor of both of these polynomials. That means if I were to divide this polynomial by x minus 2, the remainder would be 0. Same thing for this one here. Take that a step further. Because my divisor is linear, I know I don't actually have to go through and do the division either by long division or synthetic division. I know that I can just use a remainder theorem. So if this polynomial is divisible by x minus 2, that means that this polynomial evaluated at 2 should be equal to 0. And the same thing for the second polynomial. So that's what I'm going to use. So you see how we make this argument using all those things we know about factors and the remainder theorem. Okay, so let's start with the first polynomial. So if I evaluate this polynomial at 2, because x minus 2 is a perfect divisor, that'll be equal to 0. So 2 times 2 cubed plus m times 2 squared plus n times 2 minus 3. So this represents the remainder of that division, and I know that that needs to be equal to 0. And same thing for the second polynomial, that if I evaluate this at 2, so 2 cubed minus 3m 2 squared plus 2n times 2 plus 4, that also has to be equal to 0. And if you sort of take a look closely, we realize that we've got two equations in the two unknowns m and n. Okay, so let's just clean these up so that solving the system will be easier. Okay, so here what do we have? We have 8 times 2 is 16 plus 4m plus 2n minus 3 equals 0. And here we've got 8 minus 4 times 3 is 12m plus 4n plus 4 equals 0. So again, let's keep cleaning this up. So here I'll keep the 4m and 2n on the left side, and 16 minus 3 is 13. Bring that to the other side, negative 13. And here we've got negative 12m plus 4n, and here 8 plus 4 is 12. Bring that to the other side, negative 12. And before I start solving, I don't have a common factor here, but I do have a common factor of 4 in this equation. So it makes more sense to divide that out and make it simpler. In fact, I'm going to divide by a negative 4 just to, have less negatives here. So I divide both sides of the equation by negative 4. I'm going to be left here with 3m minus n equals divided by negative 4 is 3. Okay, and so now I'm going to solve this system of equations. So again, I'll work with equation 1, and I see here that the easiest thing to do to solve this system of equations is to multiply equation 2 by 2, so that I can get a similar coefficient there. So I'm going to do equation 2 multiplied by 2, so that gives me 6m minus 2n equals 6. I'm going to add, of course, since the coefficients are opposite signs, so we have 4 plus 6 is 10m. That gives me 0, as I expected, and negative 13 plus 6 is negative 7, so m is equal to negative 7 over 10. Okay, and now I'm going to take one of these equations to solve for the n value, and that looks like the easiest one. So we have 3 times m, which is negative 7 over 10, minus n is equal to 3. So I'll bring the minus n to the other side, and here what do we have? We have negative 21 over 10. I'll bring this 3 to the left, but since I need to add these fractions or subtract them, I'll write it as a fraction over 10. So 3 can be written as 30 over 10. So n is equal to, and that'll be negative 51 over 10. Okay, and there we have it. These are the values of m and n that will satisfy these conditions. So just to recap here, that while this might have looked like a different type of problem, I just used a lot of the things that we've been learning in this unit. So number one, that if I divide a polynomial by a divisor that's a perfect divisor, remainder is equal to 0, and the remainder is just given by evaluating that polynomial at this and a value, which in this case was 2. So I did that for both polynomials and ended up with a system of linear equations. Okay, that's it for this one.